So, welcome, or how we say in Portuguese, obrigado por terem vindo. I want to tell you a secret. Let's see how it goes. So, this reflects my learnings through the last 15 years of my career as a web developer, and most of the facts that I'm going to tell on this story probably are wrong. I'm more than happy for you guys to correct me as I say them, and I'm more than happy also to discuss all of them over a beer after the talk. So let's start with my story. Programming languages. Oh, great. My slides don't fit on the... Cool. Programming languages. Everything started in 1940, as everyone knows. And we started programming in assembly, and was amazing. By 1960, this guy, John McCarthy, came and invented this language. I think before this language, the only thing older than this is Fortran. It's LISP stands for Lisp processing. It introduced this novel concept, artificial intelligence, in the 60s. You can imagine how crazy this guy was. It also introduces garbage collecting, recursion, functional programming, data as code, and most of these things are being rediscovered in nowadays. Moving very quickly to 2000, because it's when I actually start coding. I don't know what happened before, but I know that all the fancy things like Smalltalk, Algol is what all languages inherited as their base. It stands for algorithmic programming. And C, Visual Basic, C#, Java, all modern languages that we use today come from the Algol family. And Lisp kind of got forgotten. So the internet appeared, 2000, I would say. The dot-com bubble also happened by the same time. In Portugal, we didn't assist that much. And these are also what we call, in Portuguese, once again, o ano das vacas gordas. And was also when this term web development appeared. We didn't spoke about web development before. There was no such thing. We start the commercialization of the web. Everyone from this year started to need a website, start to move their business to the digital era. Java, C, and all that thing. We start to use whatever we have to build these new applications, I would say, and we start to build this thing that web developer is most of the times associated with this is a client that communicates with the server and with the database. And when was the last time that anyone here did one of these? I hope that you guys are all web developers, but when was the last time that someone created one of these? Because this is like what you have every time that you speak about web development. Yeah, okay, cool. You need a server in a database, let's do it. Started out that it got a little bit more complex, and we actually have multiple servers communicating with multiple servers. We have cache, we have schedulers, we have not only this, but the browser was quite dummy by this time. So we needed also to implement all the concepts of views and MVCs and render the views on the server and serve to the browser. And then you have multiple servers that need to... Well, it's a big problem to solve. It's not as simple as we describe. Not only this, but the browser also got smarter and smarter. The browser also started to get special powers. You start to hear about Ajax and jQuery, and you start to build actual real applications on the browser. You start to have, in nowadays, the MVC, the MVVM, everyone start to build half on the client, half on the server. We start to create these big monsters. And in our days, probably like 2007, this was before we didn't have React or Angular, but we have already a pretty big mess like this one. And then in about 2008, I think was when I got my secret revealed. So if you came to this talk, if you only can take one thing from this talk, it's a secret. Web development is all about distributed system programming. So if you are a web developer, just start to call yourself a distributed system developer or whatever. By the same time, in 2008, I came to this event with another name called Subcode Bits. And was also the first time that I started having more contact with other developers, speaking with other people about new things. I was by that time a .NET developer, believe it or not. In these code bits, I had the pleasure to watch this talk of this guy in 2008. This guy in 2008 came with this talk, server-side JavaScript, open opportunity. Well, you can imagine. I think everyone said, oh God, what is this guy doing? What a crazy idea. And most of the talk of this guy was actually describing the problem that we had in the previous slides. All these crazy and convoluted systems that we were building, and we had like ORMs to abstract databases, and we have state all over the place, and we have all these kinds of complexity that comes, it's what we call incidental complexity, that comes from the fact that the systems and the programming language that we were using were not designed for the new problem. We had a new problem, and we used all the old things that we have to solve that problem. And so it turns out that he was right. He was right. By 2010, we start to have a race for speed in JavaScript. All the big players start to develop new GVMs for JavaScript. Not GVMs, new JavaScript virtual machines. Mozilla, Google, Opera, Oracle, Microsoft, everyone was doing their own thing. And JavaScript starts with the world. He was right. By 2013, I would say, 2013, I would say that JavaScript was something. We had Node.js, we had NPM, we have ECMAScript 6. People start to speak at least about it. There was some hope in JavaScript. A lot of people saw JavaScript, whoa, we have some hope. We're going to do the right thing now. Because JavaScript didn't have a lot of legacy, and we really had hope. And I got so inspired that I created Require-Alex. This is now when I show my first slide. Yeah! Em 2013. Um texto a explicar o que isto vai ser. Aceitam-se contribuições. I got really excited. I really thought, yeah, this is the future. JavaScript going to eat the world. 1 second. This was really amazing times. Was like the first functional language to get into the masses. People start to realize that we were doing I/O probably wrong with all these old languages, because they were thought when there was only one thing, not multiple of them. We start even to call JavaScript the new assembly of the web. Everything compiles or transpiles to JavaScript. So I don't know if you guys saw the recent posts, the state of art JavaScript. And I think a lot of people is being like doing the job for me. I could go in a big rant now in JavaScript why that was wrong, but you guys should read Hacker News so you guys know what I'm talking about. And is that it? Is that it what we have? So, like Mario Valente did in 2008, I'm here to say we still have hope. And this guy, cheeky. Because of the same frustration that I'm describing, decided to create Clojure, and more recently ClojureScript. And his main motto to create this is this: state. We are doing it wrong, really wrong. We should avoid state. State is the enemy. State is the enemy. And he decided to create Clojure and ClojureScript. And what the heck is this? So Clojure, you can see Clojure like this small fish that goes always with the shark. You can guess what the shark is the GVM. So basically, Clojure is, the icon actually is wrong also. This is the ClojureScript icon, but it's similar. Clojure is this symbiotic language that interoperates with the Java and uses all the Java legacy code, but gives him superpowers, and it's 100% compatible with all your Java legacy code, and brings some new tools to the table, like immutability, laziness, but we go there in a while. Then we have ClojureScript. ClojureScript is pretty much the same thing. It goes with JavaScript. It doesn't try to change JavaScript at all. It just improves JavaScript. And I'm going to focus more on ClojureScript because I think it's the big thing and is what promises more in the long term, because actually JavaScript is eating the world. So what ClojureScript brings to the table that JavaScript doesn't bring is it uses Google Clojure. This is one of the worst names in history. Clashes, the worst clashes names in history. So it's something like this. So you have ClojureScript code that goes to the compiler and the Clojure runtime, and then it emits JavaScript, and then Clojure, Google Clojure, that you pronounce the same way. They are completely different projects, and they didn't know about each other. Richie decided to use Google Clojure, that is the more performance and the best way so far to compile JavaScript. It does that code elimination and really produces highly optimized JavaScript. I can give you some examples, and there are some blog posts recently also comparing Browserify, Webpack, and Google Clojure. And Google Clojure, when you have tons of modules, is the one that keeps performing very well. I think there are some new things coming for JavaScript, but Google Clojure is being used in all big projects of Google. Gmail and all that stuff uses Google Clojure. Another thing that this brings to JavaScript that JavaScript didn't have before, it was a standard library. Google has put a lot of man's engineering power to build this standard library and to make sure that JavaScript is actually a usable language and you don't run into the famous whats of JavaScript that everyone probably already know about. So, I'm not on the slides. Okay, cool. I think you guys can have an idea what's here. So what this makes Clojure and ClojureScript special? First of all is a Lisp. Second is functional all the way. Immutable data structures. Is lazy, and this is only my favorites. There's much more things. All of these were invented pretty much on the 60s. This is nothing new. They have much more high-end technology that I will not go through because I think it's too much. And so this is what I'm going to try to show you guys. I don't know if I'm going too fast, if anyone has something to say or anything. I'm now going to jump into code. So, jumping into code. This is also the time that I need to mirror my screens. Cool. So, code, but first, this thing, parentheses. Wait a second. I need to move out of mirroring because I need my notes. You guys have nothing to say? Okay, so first the code. Let's jump to the code, but first let's speak about parentheses. Everyone that goes to Lisp languages complain a lot about parentheses, but I don't really get. Everyone has a parenthesis on their keyboard. They saw them. It's only on different positions. And most of the complaints that we have now doesn't make sense anymore because you have IDEs, you have text editors that have a lot of things to solve this problem. This is a problem solved. If your reason to not go to Clojure is because of the parentheses, guys, Chinese, I don't understand anything Chinese. Doesn't mean that Chinese is unreadable. And it's not easy because there are people that think Chinese is easy and our language is hard. So don't make this as a barrier to go to this language. And about tooling. This is one of the things that I'm doing differently from the presentation 2008, that Marivalent showed everything was like what could happen. That was why it was called open opportunity. Here you can go back to your seat, download IntelliJ or Cursive, that's what I'm using here, and start coding straight away. You have all the tooling and everything works pretty much very good with Clojure. So now is the time when I go to the REPL. Okay, cool. So, cool. So let's. So for you guys to start reading Clojure, I will start by explaining you what are the primitives of the language, and from there I'm going to the data structures and so on and so forth. So you have all the basic the primitives that you have in all languages. You have integers, you have doubles, you have ratios. Ratios are quite special. Ratios is a way of represent decimals, and instead of doing the computation when you find the decimal, it uses the ratio until you actually evaluate everything, so you keep the precision until the last moment. You have strings, you have characters, you have these special guys that probably you never saw before, that are keywords, are very handy. You have booleans, you have nil, there's no null or undefined, it's only nil, and means nothing, nil, no. You have regex patterns, and then you have lists. Lists are quite special on Clojure, and this is also what makes one of the big difference from traditional Lisps, is that code in Lisp is represented by lists, and traditional Lisps only have this to represent code and data structures. They only have the parentheses. In Clojure, you have more stuff that I will go in a second. But lists are, as I said, also used to represent code. So, for example, if I come here and I evaluate this thing, it will print me line hello world. So lists are used to represent data structures and code. Bear in mind, lists are not that much used. People use vectors, are the array kind of things. Then you also have maps. Maps are pretty much the same thing of a JavaScript object. Everyone is familiar with. The difference is that in maps, if I define a map, that is something like this, and then I want to retrieve the properties of the map, because this is a functional language and everything is function calls, how you retrieve the value of a map is by passing the keyword to the map. And you see, so keywords are also functions when using in the code. This is I'm giving you the primitives and the basics so you can read the code moving forward. But not only keywords can be used as keys, but also strings, numbers. You can nest all these things. You can really nest all these things. You have def, that is a special form that comes by default with the language. You have also defn. that is to define a function. So I can define this average function, and I can then call the average. And then this also have another particularity. You can find this strange. So in the list, so okay, coming back. I don't know if I'm going too fast. I see your faces. Okay, cool. Any questions so far? Yeah, of course. To make sure that I see that is a common. No, it's a preference. Yeah. One is okay, you can use one. And you can also use this special thing. This also means comment. This also comments code. That is very handy for live coding, because this bit of the code is not evaluated when I run the program. It's only when I evaluate manually. Excuse me? The special parentheses? I don't know. Ah, okay, yeah. So the difference between the parentheses and the brackets are, parentheses are used to represent data structures and code. So for example, so for you to understand the difference, if I try to evaluate this expression, so if I try to evaluate this expression, it says that call is not a function. Because if you use lists, the parentheses one, it tries to evaluate the code. And the rule is that the first thing inside is a function. That's the rule. And if you want to actually create this data structure, you need to use this form, and then it gets evaluated. I'm sorry if I was too fast and you guys didn't got that. So continue. You have functions. You can, so the first thing is always the function call, like this. And for example, if I do a sum, it's 2. And you guys can say, oh, this is very is not readable. But it's very handy, because if you want to sum 3 numbers, you keep appending them. And if you want to sum 4 numbers, you keep appending them. And for example, the function that I defined, the average, if I want to do the average of 3 numbers, I only need to add a new parameter. In other languages, this is quite hard to achieve. For example, and because of this you can do very compact code that does a lot of things. And you can argue that is good or bad. I would say that is good, because the only relation between bugs and programming languages is by the amount of lines of code that you produce. So if you produce less lines of code, you have less bugs. That's the only relation that I find. Yes? That is also a better? And you read from inside out. Yeah, sure. Here. The first line? Def n. Def n is, so you have the def. Def defines a persistent data structure, and def n defines a function. You have more ways of defining functions. This is if you want to give a function a name. This is the number of arguments. Oh, okay. This is the argument. So you can also do this. This is an anonymous function. This is what? Well, it should evaluate. I don't know. Oh, I'm not. Well. Here is the number of arguments in brackets, and then you have the forms that will get executed once the function is called. So you have really these data structures are really rich, when I mean rich is, I don't know if you guys noticed, probably some of you already saw where this is going, but I'm inside of my presentation doing live code, and I can move my slides back and forth. So if I click previous slide, this goes to the previous slide. If I evaluate next slide, it goes to the next slide. Not only that, but I can also change my code live. I can come here and say that this is not tooling anymore and is tools. Should have changed. No, I'm on the wrong slide. Wait. Here we go. You also notice that I don't have GSX like any like JavaScript when you want to do React or anything, because Clojure data structures are so rich. You can represent HTML quite easily without needing something else to help to represent HTML. You can even represent CSS. We have Garden that is pretty much the same thing. It's like more data structures that you have to create style sheets. It's all about data structures, function calls, and it's very easy. Once that is the thing, is simple, not easy. It's not easy to get started, but once you start and you get the basics, everything is very similar and everything is the same. It's not much more to learn. It's harder to get started. Once you get started, you are fine to go to every kind of scenarios. Coming back to my presentation. Code functions. How much time I have? Okay. Cool. So let's continue to the slides. I need to move this back to not mirroring. Cool. We are back. So, speaking about tooling, we have to start building Clojure apps. You need to learn Lannigan. That is the de facto Clojure build project, I would say. And if you guys are familiar with the Node.js, it's pretty much the package.json. I can give you an example of a project.clj for this application that I have here, and you will find like it's where I define how my ClojureScript builds. It's how I define my fig view, that is my library load and all that stuff. It's where I say what are my entry points on the application. I even compile gardens here, and I say what are the dependencies. And this is another cool fact about Clojure is all these dependencies. So I'm requiring the whole language. I have access to the whole language in runtime. I can say like, I don't know if I can see this. Let me try here before. 1 second. No, I don't know. Whatever. You can access the language, the whole language live. So basically, you can, for example, any function from the core Clojure or core ClojureScript, you can run a function that gives you the documentation of that function while you are executing the code. And everything is okay, because then in ClojureScript, it does that code elimination. So it's okay for you to have the whole language while you are developing. If you don't use the functions, then when it gets bundled, you remove that code. I'm kind of lost now, to be honest. So you guys got this bit of cool. One second. Okay, so Figwheel is the de facto tool also to live load, is what you call the Webpack or Browserify. It does all in one. It's very easy to get started. It's through 2 or 3 commands. You compile, you config the project.clj. You say where it's the entry points of the script, and it starts running. So you have Clojures. That is like NPM. That is where you find your modules. And speaking about frameworks and all that stuff, this is once you want to start using ClojureScript, you also want to have your React. So this is the wrappers around React that we have: Home, Agent, and Run, and Redescend, and a couple more of them. And one funny thing: these guys, when they start building ClojureScript, it's pretty much, it only made sense once React came, because React made possible to represent the view in a function. And these guys created Home, and Home, when they first start using Home with React.js, they got about 6 times faster than React in JavaScript, and they were transpiling. And the reason for that is because of the immutable data structures. And now, today, if you go to React.js website, you go to the performance tab, and you see that if you really want performance, you need to use Immutable.js. So these guys started the trend and showed that Immutable is a very good thing to have. Yeah, there's a lot more things to speak about, but I think we're going to stay here. I don't know if you got... We have immutable data structures. That is the fact. So this is the more frustrating thing, probably, immutable data structure, when you start, is that you cannot change stuff in place. You can never change any variable that you define. Is taking your favorite tool away. It's like, how you program with this then? Once you imagine you define a variable, and you can never change that variable. The way to see this is like, for example, the number 2 and the number 4. You never change them. They are always there. They are always around. The number 2 is always the number 2, and the number 4 is always the number 4. You only derivate data. You sum 2 and 4, and you have a 6. But you don't change the 2 or the 4. But normal programming languages mix all this stuff together. They give you both options. And Clojure is by default immutable. By default. Another cool thing that you have in Clojure once you start coding is the CSP that got famous with Go. That is communicating sequence process that is to do asynchronous programming. And these guys from Clojure managed to implement CSP without rewriting JavaScript or Java or anything. They have a thing called macros that they can change their code as it goes. It's a very strange concept. I don't want to go there also to not confuse anyone. And these guys even go further. This guy create Datomic, that is an immutable database. Imagine all these concepts that I'm describing applied to a database. It's a database that you can never erase anything. It's like an append only, but not only appending. It's creating much more behind the scenes. Cool. And that's pretty much what I have for you guys. Questions? 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 Anyone? Yeah, there's a mic there.
Can you talk about debugging?
Excuse me?
Debugging.
Yeah, sure. Nice call. Thank you very much. Because that's a must-have. So, this is my presentation. You saw that this is running a Clojure app. correct? And I'm going to show you then this. So let me mirror the screens 1 second. Cool. So you can see this, and we can also see this. You can also see this. You can see this. So I'm going to do a typo. Well, it's not possible to do a typo this way. Let me do a typo. Let me do a typo. Yeah. So this is Figwheel in action. Figwheel gives me code analysis live and says me what is the line of code and what happens. I just changed the line of code. So basically this slide was called slide 28. Something is using slide 28 and slide 28 is not there anymore. And Figwheel straight away in my application didn't stop running. That's the cool part. So my application didn't stop running. Figwheel realized that while the code was compiling there was an error, and it just didn't push the code through, only the error. And now you can save again, it refreshes, and your application continues to run. How cool it is. Anything else? This answers your question about debugging? Yes. Excuse me? JavaScript is compiled. Yeah. So basically all the Clojure data structures are compiled to JavaScript. No, not at all. But you don't need. There's no reason to go read that JavaScript. That JavaScript is changed by the Google Clojure compiler and has nothing to do with it. It's highly optimized, and most of the times, for example, I have here, if you want to see, for example, you have three types of give me a second. I was about to put this on my slides, but then I didn't. But I'm glad that you asked. So you have this first type of compilation that basically you given this JavaScript, it produces this kind of JavaScript. This is the simple. And then you have the advanced mode. The advanced mode, it produces something like this. It realizes that you are passing always the same stuff, and it lines everything. This is highly optimized JavaScript. This is the kind of things that Google Clojure Compile does for you. So, but you don't want to see that. You just trust them. And then you have the Figwheel debugger live that you saw in action. That, for example, if I come here and I do something that doesn't exist, you will tell me that no, this is not going to compile. Any other question?
Yeah, I have one. What is the compatibility between Clojure and ClojureScript? I mean, I know ClojureScript builds on top of Clojure, right? But can you share libraries? Can you run a library, build a library for Clojure and share it on ClojureScript? If not, why isn't ClojureScript using NPM for storing the packages?
So, yes, you can. There is a project that was a Google Summer project that basically basically that's a Google Clojure with an S problem. That's why we cannot use NPM modules straight away. But there was a Google Summer camp that happens every year, and a girl actually made Google Clojure compatible with NPM modules, and it's a matter of they releasing the new ClojureScript release that have that changes and uses the new version, and we can use all modules from NPM.
But if they're compatible, so you can use the Clojure library in ClojureScript, right?
No, because they are to Java. But you have a special file. What you have if you want to share code, you have ClojureScript files, and there's CLGS. And
right.
Clojure files and the CLJ. And if you want to share code, you have a CLC that then you annotate the code. You do, because this is very rich and code is date and date is code. You come here, you do this, and you say this is plus CLGS, something like this, and you give the version of how this runs in CLGS and ClojureScript, and you give a version to Clojure, and the compiler, depending on the environment, picks up the code that is interested in. Okay. So yes, if you want to know if this language probably is also the one that is able to promise what everyone is saying, that is running JavaScript on the client on the server. This allows that kind of things, and even using all Java libraries in server.
Yes, I know Clojure, a bit of Clojure, but not ClojureScript. So I know that you can use Java on Clojure. Yeah. Okay, thank you. And
you can create files that know which one. For example, when you require almost of the core language of Clojure, they need to make, for example, the date time. When you're using ClojureScript is one version, and when you're using Clojure is a different version.
Okay, but it's the same interface.
It's the same, and the compiler picks because they annotate which type of code should be used.
Okay, cool.
So yeah.
I have one other question, but I don't know if I'm jumping in front of someone. I'm going to ask it anyway. It was, does it have source maps when it compiles to? Does it produce source maps?
Yeah.
Okay.
Yeah.
Okay, cool.
Yeah. Most of the times we don't use because Figwheel hides all that complexity for you, but you can go to the Figwheel properties and you can specify a path and it will work.
And you can debug ClojureScript code on the DevTools.
Yeah.
Okay.
Definitely. I can show you that is
okay.
Right. So if I go to here, I open this thing. And if I go to source, I go here, and I have all my code. So I have all the ClojureScript actually. I have all Clojure, because I'm not compiling to production, I'm doing the basic compilation. I have all the ClojureScript code, and my thing is this slide. This is my bit of code. This is the Google library. So this is everything that Google gives you to use.
Okay.
But these are my slides, these ones. And for example, if you come here to the content one, this is the JavaScript version, this is the compiled version, and you can come to the ClojureScript version, and you can see.
You can put breakpoints there.
Yeah.
Okay.
Everything works.
Okay. Thank you. Thank you.
Any more questions?
You mentioned that you can use all of ClojureScript and all of Clojure, and during the compiling process, the compiler throws away all the functions that you do not use.
Yeah, that code elimination, yeah, but only in ClojureScript. In Java, they don't have that problem.
Okay, but how does the compiler know what you are using or not using? Because this is a very dynamic language.
Don't ask me. That's not a problem that the guys from ClojureScript needed to solve. It's a problem solved by Google Clojure compiler. If you go, Google Clojure. So if you want to know how that problem is solved, you need to come here to Clojure with an S, and you should read how they do it. It's Google that solves that problem for us. And it's they have more than 10 years of this thing going on. For example, all Gmail, all modern apps that they have in production, they didn't build with Angular. They built with this thing. And this thing it also ensures compatibility to IE6. IE6, backwards to IE6. All the code emitted by ClojureScript and Clojure compiler is compatible with IE6. Except if you add React, then you stop to have that compatibility. Any other question?
I have another one. Sorry.
Shut it.
Okay, so you were loading you are not compiling right now, right? You're in a mode where each one of the files is standalone, right?
What do you mean?
So the browser loads, in that mode that you're running, the browser loads one file per time. It's not a bundle, right?
You can if you go to the console, you can see what are the files that they are loading. So it's there, which one they are refreshing.
Okay, but you can produce a bundle, right, with Clojure?
Yeah.
Okay.
That's what I would do if I want to deploy this. Yeah. I would enable advanced mode, and I will produce a single file, and that's what I will serve. And then basically you then expose your entry point of the application with an export. So you go to your core and you export this thing, and you have this available on the window document.
Okay. Cool. Do you have any experience using ClojureScript to create node modules on the back end? Is it possible?
Yes, it is possible, and there are some people doing that, but not that I know.
Okay.
But it's possible, of course.
Okay, cool.
Yeah, but the model will be unreadable at the end of the day.
No, but okay.
Yeah.
But
you need to have the.
You have to some compilation
and you then will end up. For example, all these things I started like the CSS because for me was easy to copy paste SAS because there are more on the internet. I copy paste some SAS, so I have here Node.js running. So you'll end up with a project that is quite convoluted with multiple runtimes and multiple things.
Okay.
But it's possible, and I think there are some examples of this already
so
happening.
The thing is how to create modules. Exporting an interface in a module. Does that relate to all? Is it possible to do that on Clojure? Stuff like that. I would be interested in.
Yeah.
Okay.
It's all possible. Yeah.
Cool. All right. Thank you.
Thank you for coming. Obrigado por terem vindo.